Good morning. I am Srinivasan Silvaraj. My mobile number is in country code India, so +91, and mobile number is 75502465667. And we are doing research and development and also training. Our company name is SSI Embedded Foundations. We are doing excellent. We are doing and providing excellent training in embedded system to the people from India, Chennai. Our email ID is ssembeddedchennai@gmail.com. ssembeddedchennai@gmail.com. Today we will see special function registers. The special function registers are registers used by the CPU and peripheral models. So, in a microcontroller, in a processor, if you say general purpose register means through program you can store data. If we say special function register means that registers also used to store informations, but that is specially assigned to peripherals like input output unit, port A, port B, port C, and ADC, DAC, capture, compare, PW. So for these peripherals, what are the information you are storing? No, that information stored in registers only. That registers comes under special function registers. These registers are implemented as statigram. A list of these registers is given in table. This is about PIC-SysNF 877A. Not only PIC-SysNF 877A, for all microcontrollers. The special function registers can be classified into two sets, core and peripheral. So it is classified core used. This special function is used by CPU and peripheral. Those registers associated with the core function, that is CPU function, are described in detail. Those related to the operation of the peripheral features are described in detail in the peripheral features section. Okay. So if you say special function register means that is used by processor and also peripherals. What are the special function registers in PIC-SysNF 877A is name, INDEF register, timer 0 register, PCL register, status register, FSR register, port A register, port B register, port C register, port D register. All registers are 8-bit because this microcontroller comes under 8-bit microcontroller. Okay, port A register, PC lathe, INCON register, PIR1 register, PIR2 register, timer 1 L register, timer 1 H register, timer 1 control register, T1 con, timer 2 register, T2 con register, SSBF register, SSP con register, CCPR1 register, capture compare register L, CCPR1H register, CCP1 control register C1, RCSTA register, TX register, RC register, CCPR2L register, CCPR2H register, CCP2 control register, address register, ADC control register. This type of registers comes under special function registers. Then INDEF register, option register, PC register, again same registers only. TRIS A, TRIS B, TRIS C, TRIS D, TRIS C, TRIS register, direction register. This everything we will see one by one. Okay, in register section. First we will see the status register. The status register contains the arithmetic status of the ALU, arithmetic logic unit, the reset status, and the bank select bits for the data memory. In this PIC-SysNF 87A register, the status register contains the arithmetic status of the ALU, the reset status, and the bank selects bits for data memory. So normally if you take any microprocessor, this register is called status register. By reading the status register or by know the value of the status register, bits in the status register, we can see, we can know the ALU function and the status of the reset and the bank selection of the memory. Okay, the status register can be destination for any instruction as with any other registers. If the status register is the destination for an instruction that affects 0 flag, DC and C bits. Okay, so in status register you have the Z, DC, C bits. See, Z is 0 flag, DC is digit carry, C is carry bits. Okay, then the write to these 3 bits is disabled. These bits are set or cleared. That is, if carry is there, C bit will become 1. If the digit carry is 1, then DC become 1. If result is 0, 0 flag will be set. That's all. Okay, the TO bar PD bits are not writable. Okay, see, if you take any special function register, some bits you can read and write, some bits you can't read, you can't write, you can read. Okay, that's the for that in this status register there is a TO bar PD bits are there that we can't write. Okay, that is for reserved for CPU. So if we take status register, this bit 0 is carry C. So if any arithmetic logic operations carry bit set C, this bit become 1. C and DC digit carry. If any arithmetic operations, if digit carry is set, then this DC bit become 1 and 0 flag Z. Okay, then bit 0 is C, bit 1 DC, bit 3 is bit 2 is Z 0 flag, bit 3 is PD bar and bit 4 is TO. We will see later PD bar and TO bar. And RP0, RP1 I already explained, it is for bank selection. And IRP for interrupt. Okay, now IRP register bank select bit used for indirect addressing. I said no indirect addressing. If RP1, if IRP bit, that is bit 7 in a status register, bit 7 is IRP. If IRP is 1, bank 2, bank 3 of data memory will be selected. We know very well, data memory RAM, static RAM, no, is divided by bank 0, bank 1, bank 2, bank 3. So you want to store any data, select the bank. For selection of bank, IRP in status register, bit 7 is IRP bit. If IRP is 1, bank 2, bank 3 will be selected. And if IRP 0, bank 0 and bank 1 will be selected. And RP0, RP1 I already explained for bank selections. If it is 1, 1, bank 3. If it is 1, 0, if it is 1, 0, bank 2. If it is 0, 1, bank 1. If it is 0, 0, bank 0. Each bank 128 bytes and timeout bit TO bar is timeout bit. If it is TO bar is 1 after power up, clear watchdog time instruction or sleep instructions. Okay, after power off this bit become 1 and 0 is a WD timeout occurred. If watchdog timer is working, okay, if it is selected, this TO bar becomes 0. If it is 1 means the CPU processor is in on state. PD bar power down bit. If it is 1 after power up or by the clear watchdog instructions, 0 by execution of the sleep instruction. If BD bar is 0, processor is in sleep status. So for power on, if the microcontroller is on means TO bar is 1 and PD bar is 1. If PD bar 0 means sleep instruction is executed. That's the meaning. And then 0 bit. If it is Z bit, which bit is Z is bit 0, bit 1, bit 2. So if bit 2 of status register is called 0 bit Z. If it is 1, the result of an arithmetic or logic operation is 0. If it is 0, the result of an arithmetic or logic operation is not 0. Then DC, digit carry or borrow bit. Okay, if it is DC, that is bit 1, this is bit 1 of status register. If DC is 1, a carry out from the 4th low order bit of the result occurred. If it is 0, no carry out from the 4th low order bit of the result. If carry C is 1, a carry out from the most significant bit of the result occurred. If it is 0, no carry out from the most significant bit result occurred. Okay, this is about status register.